In this experiment, we're going to start looking at some of the properties of light. And to do that, what we're actually going to do is we're going to use some lasers. So I've got two different types here. I've got just a little laser pen, and I've also got a little laser box here. Now, a couple safety things. First of all, do not look into the laser light. Okay, looking straight in can cause damage to your eye. On the same note, don't shine this light at anybody's face. Okay, be very, very, very careful when operating this equipment because we don't want to damage their eyes. Okay, so I don't know if we can see it. Yeah, I guess you can with this. You can see that I got a green laser light. They might come in different colors. This one here is a single. See if I can bring it across. You can see a single beam of light. It also has a triple beam. See if I can get three of them here. One, yeah, you can't quite tell. And it also has a 5-beam ray that can come at you. Okay, so what I'm going to do is we're going to shine those across the room here just so you can sort of see them on the far wall. And I'm going to make the room a little darker just so it's a little easier to see. We're not going to do the lab in darkness, but just so you can sort of see the lights. So hopefully you can see that in the room. That's a 5-beam. There's the 3, but we'll just go to a single beam of light. Okay. Now, let's talk more about the lab specifically. Here you can probably see the single laser beam a little more clearly. There we are with 3 beams, and there we are with 5. And the laser light is always wonderful because it gives us a nice, crisp, straight, universal direction beam. And what we're going to do really in this lab is we're going to take some objects and put them in the path of the light and see what it does to it. Okay. So I don't know if you can see it with this angle. I'm going to adjust my camera a little bit. Here I've taken, don't know if you can see it. It's like a half moon shape. I've got the flat side here facing the light. And you'll notice that the light has curved and bent, and it's meeting at this point right here. So this is my focal point. That's what it's called. It's called a focal point. And different curves of lenses have a different length of where they meet. And that's basically how glasses and contacts work for those that don't have perfect eyesight. Okay, let's see if I can take a different shape here and see what that does. Okay, once again, a little bit different. This one has a curve on both sides. Okay. What if I took a triangular one? Whoa. So the two on the outside don't go through this prism. But the other ones in the middle, the 3 in the middle, are getting bent. And you can definitely see the bend. And if I look down from the top, I should be able to see the actual path. Where is it? Of where the light, you can sort of see the light comes in, hits, and is being bent, and some of it's being reflected as well. Okay. What else we got here for shapes? This one's kind of cool because it's hollow. I'm going to fill this with water, and when we fill with water, we can let it be reflected and refracted by water. Okay. So, here's a couple more. Here I have just a straight block. You can see when it's straight on, it does nothing. But if I turn that block, you can see how the light is being bent. So it comes in, then it bends, and then it leaves the block and it bends again and goes back to parallel lines where we had them. Okay. And was there one more? Just very much the same. The other thing we can do, it's kind of fun, is we can actually start putting multiples of these together. So I could put, what if I had that one followed by that one, which then has this one. Okay, and we can see all kinds of different patterns. So part of what you want to do in this experiment is just explore and play with it. See what you can determine from it. Okay. You're not going to use the box laser. You're going to actually use the single beam pen style laser. This one happens to be green. Some of them are red or blue. Okay. And you're going to shine these through. Let me give you a little more detail how that's going to work. Like we do with any good experiment, we're going to take at least 3 different sets of data for each of our trials, just to make sure that we've got some consistency in what we've collected and a little more reliable in our data collection. So what are we going to need? We're going to need a few pieces of paper and a pen or pencil, and you're going to need a protractor. And we're going to start, we're just going to draw a line. Okay, so there's a line. And this is going to be our incident ray coming in here. So that's where we're going to line up our laser light along that line. Okay. Next, we're going to pick the object. So here I've got some kind of trapezoid, and I'm going to have the trapezoid. So I'm going to put it on there. So it's right where that incident ray ended. And now I'm going to trace around my object. Do a really good tracing job. Okay. So there we are. All right. Now what we're going to do is we're going to shine our light through there. Make sure you've got it lined up. Okay, so I'm just putting it right down the line. There it is. And while I hold that, what my partner's going to do, okay, once again, make sure I got that going right to the spot I want. What my partner is going to do is my partner is going to look, and you can see, if you look down, you should be able to see the ray come through the prism. And I see that it's coming out right here. And I also see that it's going over right to here. Okay, so now I can release that. And I've got my page marked. And what I can do is I can now do 2 things. One is I'm going to connect those 2 spots. So I now have that ray. And you'll notice that those are actually parallel to each other. Okay. Then what I'm going to do is on my diagram, it went in right here and it came out right there. So I'm going to join those 2 spots. And you'll notice that I do not have one continuous straight line. It goes straight, then it bent, and then it went straight again. Okay. Using my protractor, I can draw a 90-degree angle at both the entrance and exit points of my prism. I'll draw that as a dotted line. Okay, doing that on both. At 90 degrees. Oh, not quite in the right spot. There we go. And if I've done a good job, those should be parallel, which they are. Good. Okay. Now I can label my diagram. Well, this was my incident ray here. So this angle here is my angle of incidence. So I've called that theta I. And this angle right here is theta R. Now, I'm going to label the second one. Instead of using theta, I'm going to use beta I and beta R. Okay, so I've got this. I've got it labeled. This is air. This is air. I don't know what this thing is. So what is my N value? Well, the N value for air is like 1.000, was it 10029 or something like that? Okay, so what I can now do is I can now calculate from this one diagram, I can calculate N 2 times. So now I can calculate what the N value is for the mystery substance. So I'm going to look at my Ni times the sine of theta I equals N of R sine theta of R. And I can find, using these 2 angles right here that I can measure, nice and close here. These two angles here that I can measure, I can calculate the R value or the N value of the unknown substance. I'm then going to do the exact same thing for these two angles, okay? And I will have one trial, average those. Then I'm going to repeat the entire process a second time using a different angle of incidence on the same prism. Okay? We're going to do that 3 times on this prism, and then we'll take another prism and do it 3 times on something else. Okay? I'm recommending you pick ones that have flat sides. Okay? The curved ones get a little tricky. Okay? But you can use those when you're playing around with your substance just to see. Okay, so we're going to do this, let's say 2 of the 3 substances, you're going to find that. The N value, you're going to do 3 trials on each one, and you're going to do 2 different ones. So to repeat, this lab has 3 parts. Part 1, you're just going to take your pen laser light and play with the different shapes, right? Play with the rectangles, the triangles, the hemispheres, semispheres, and just see how the light changes. Part 2, you're going to do it 3 times, and you're going to find the index of refraction of the material that you have, and then you're actually going to Google and see if you can figure out what is the material, what is that plastic made up of that those things are. Here we have our third part. I've got water in here, okay? I got water. Careful when you do this so that you don't get your page wet. So don't get the outside wet, because then your page is going to start to rip. So I've done the same thing as before. I've drawn with my straight edge. I drew a line of incidence, and I've traced around my object, and it has water in there. And then I'm going to do the exact same thing. I'm going to take this, and I'm going to shine it through. Once again, my partner is going to indicate where that is coming out, which is right there. Okay, so there's where it is. And now what I can do is connect those, and you can definitely see that bent. Well, we know that this is water, so that has an N value of 1.333, and this is coming from air. Once again, we should label our diagram, get our right angles and so on in here. I'll do this pretty quick. Okay, so this is my angle of incidence. This is my angle of refraction. We're going to measure this angle here. Okay, and we're going to measure this angle here. And once again, we're going to do this 3 times. We're going to get 3 different sets of data, and we're going to calculate. We're going to calculate let's calculate N. We're going to determine N for this one. We know that was water inside the container. So what we're going to do is we're going to find N. So we're going to find N, and then what we're going to do is we're going to average our 3 samples, and then we're going to do a percent error, knowing that we should be using 1.333 as our accepted value. Okay, so once again, find the percent error of the N of the water and the N that you've done in the experiment, and find the percent error. And then see if you can find 3 sources of error. And by find, I don't mean Google. I mean, look at what your experiment was and where did you make mistakes? Why are you not getting a perfect answer?